Hi everyone, welcome to YourPedia. This is Chandrasekhar, faculty of physics at YourPedia. In this video, we are going to solve all the problems that were asked from the concept current electricity in the AAI ATC examination. Okay, all previous questions we are going to solve and we are going to learn concepts through problems. Subscribe this channel for this kind of more videos for your learning purpose, right? So AAI ATC is one of the prestigious job, you all know that, right? So soon the examination is going to be conducted in 2025. Okay, yeah, we are going to see the previous questions from the topic current electricity. See, from this topic every year whenever the examination is conducted, at least two questions will be asked, and the questions are quite easy if and only if you learn the concepts in right direction, right? Let's go for the very first question, that is when the EMF of two cells is compared in a potentiometer experiment. What is a potentiometer, sir? Potentiometer is the one which is used to measure, we can measure voltage or we can measure resistance also. For both the purposes we can use, but here we are going to standardize it first of all. Yes, potentiometer is used to measure the resistance. Sometimes we use for measuring voltage also, right? What is saying? When the EMF of two cells is compared in a potentiometer experiment, the ratio of balancing length is obtained as 2:5. What do you mean by that? See, I'm writing here, there is a wire of length L, okay? Let's take it as L, okay? So this is potentiometer. See, in potentiometer we will use wire, okay, on which we are obtaining the balance of an cell or EMF. So he is saying that 2:5. Yes, balance is obtained at 2:5. If one of the cell has EMF of 1.2 volts, then the other cell's EMF is, okay, 2:5. Yes, one cell at 2, another cell at 5, means the ratio it is, right? So I can take it as, see, total L, I'll assume it as 7, or this way I'll take, yes, this way I'll take. See, 2/7 times of L is the first cell balancing length. Why? Total I'll take it as 7 parts, 2 parts, 5 parts, total parts. This is little aptitude we need to add. 7 parts. Out of 7 parts, 2 parts at the second part. Okay, one cell is getting balanced. 2/7 L. The voltage is 1.2 volts. Sir, why you are taking this 2/7 as 1.2? Why it is not 5/7? Yeah. Why not it is 5/7 L? That also is possible. That's why two answers are there in your choices. Two answers are there. Okay, let me take a fresh page. There I do it very clearly. Come here. He's saying that 2:5 means total parts are 7. Total parts I'm taking it as 7. In that one cell is obtaining balance at 2 parts, means what? That will be 2L/7. That voltage is 1.2 volt. For 2/7 L it is 1.2. What is remaining? 5L/7. How much is the voltage? We don't know. How much is the voltage? We don't know. Cross multiply it. 2L/7 into E is equal to 1.2 into 5L/7. 7 gone, L gone, right? Then E is equal to 1.2 into 5 divided by 2. 1.2 into 5. 1.2 into 5 divided by 2. How much it is? 0.6 into 5. So that is 3 volts. Okay, sir, got it. But sir, you assumed one of the cell at 2L/7. What is the case if it is getting for 5L/7? That is also, see, he given 2 cells. He mentioned that one of the cell got balance at one length. See, let's come back here to the question. He is saying that, okay, the ratio is this one. If one of the cell, so which cell got at 1.2, he did not mention. Maybe this ratio cell, maybe this ratio cell. We taken this ratio cell got balanced at 1.2, then I got other cell EMF as E. How much it is? 3 volts. 3 volts. So option A is not correct. Option C is also not correct. Either option B or D, because we got 3 volts. Yes, 3 is there here, 3 is there here. Let's find other cell EMF also. Means other possibility also. What is other possibility? We assumed that, yes, I'm writing here. Suppose if 5L by 7, the voltage is 1.2 volts, then yes, at a 2L by 7, the voltage will be E, right? I don't know E. Let's calculate it, cross multiply. 5L by 7 into E is equal to 1.2 into 2L by 7. 7 gone. Yes, LL gone. So E is equal to 1.2 into 2 divided by 5. How much it is? 2.4 divided by 5. Yes, 5 fourths it is. Yes, 20. Yes, after that 8. It is 0.48 volts. E is how much? 0.48 volts, very clearly. So which option is suitable, ma? Exactly option B is suitable. The concept of potentiometer is, if you take a length of L, wire length, it is going to have a resistance of R per every meter. Then you are applying some cell or EMF to it, and the drop we are comparing, where we are getting the balance, then by that we are going to find the voltage. Okay, that way we are going to find the voltage. Okay, potentiometer, that is the application of potentiometer, right? Let us go to the next question, please. Next question is saying that the EMF of 2 batteries with internal resistance is connected in the circuit shown below. Okay, yes, this is the circuit. It is clearly visible to you. The equivalent EMF and internal resistance of the circuit between terminals A and B equal to, he given three batteries. This is a battery. See, this is a battery with 2 volts and 0.1 ohm. I represent that this way. Though he wrote the resistance, but he did not represent it, but he wrote the resistance, we can represent this way. Any voltage source internal resistance will be represented in series. I repeat the statement. Any battery's internal resistance must be represented in series. He given the value, but I am representing it. Why? Because further I need to convert it into other form, right? And this is a 4-volt battery, but it is also having resistance. But you see the polarities. This is plus, this is minus. But this is minus, this is plus. Bigger plate is positive, smaller plate is negative, right? How much is this? This is 0.2 ohms. It is. The next one is 6 volts. There is a resistance, and yes, this is 6 volts. This is plus, this is minus. This is plus, this is minus. And this terminal is A. This terminal is B, right? A and B. Now, he is asking, if I want to represent this one happily with one simple resistance this way and one voltage source, then what is this equivalent? Means what he is saying is, brother, you simplify this entire, get a simple one like this. And in fact, he is not representing this resistance in the diagram, but he is mentioning the resistance here. Both are correct, right? Now, how to do this, sir? How to do this? Observe here carefully. I am going to do it. Observe here, all of you. See. Now, one statement we need to learn here, that is, voltage source in series with resistance will be converted to current source in parallel with resistance. Yes, I am writing a note statement here, which is, so if we know this, problems are going to be quite easy for us. A voltage source, yes, a voltage source, yes, in series with resistance, in series with what? Resistance will be converted to a current source, yes, in parallel, yes, in parallel with resistance. What do I mean by this? And vice versa. Means what? What do you mean by vice versa, madam? Sir, yeah, what is the meaning of vice versa? Voltage source in series with the resistance will be converted to current source in parallel with the resistance. Suppose if you have current source in parallel with resistance, that will be converted to voltage source in series with resistance. Vice versa, it is vice versa. Let's do that. Okay, I'll come back to this there itself. Okay, now what is the meaning of my statement? If I have a resistance in series this way, this is plus, this is minus, if this is V, this is R, okay, this will be happily written as a current source. This is a symbol of current source in parallel with same resistance, this R only here. So then what is the value of this current? That current I is equal to this voltage divided by that resistance. Yes, this voltage divided by this resistance will give some current, and the same resistance here, or what is its vice versa? I have a current source of I in parallel with the resistance R. Yes, that will be converted to, yes, voltage source, same resistance in series with voltage V. That V is equal to I into R. That V is equal to what? I into R. Right? Yes or not? But here arrow direction and plus minus are very important. If plus is upside, arrow should be upside. If arrow is upside, plus should be upside, right? If plus is downside, arrow direction of the current source should be downside. The same concept I am going to use here for this question. Observe all of you carefully. Very simply we do this. And one more thing, voltage sources in series will be added with their polarities, current sources in parallel will be added by their direction. Means what? That also, let me take up that also, then I go to that question. Means what? Suppose there is a battery, this voltage plus minus, let's take it as 10 volts. There is another battery, let's take it as this is plus minus 5 volts. These two are connected in series, okay, series connection I made. Now this total will be 15 volts. Yes, this total is 15 volts plus minus 15. Why it is 15, sir? Why you did not subtract it? Because voltage source minus is connected to plus, both will be added. Plus connected, subtracted, plus minus connected, added, minus connected, subtracted. Opposite polarities are connected in series, the resultant will be the addition. Okay, same polarities are connected in series, result will be subtraction, right? And suppose if I have a current source like this is I1, for example, I have another current source like this is I2. Okay, let's take it as I2 is equal to or for your understanding purpose, let me take one simple change I am going to take up here. That is here I2 5 amperes I am taking, I1 is equal to 15 amperes I am taking. These two are parallel connection. Now this is up, this is down, both are in opposite direction, up and down, subtraction. Okay, up addition, down addition, down up subtraction. Okay, yes, now the resultant current will be, sir, then which side I need to put the arrow? Which one is high? 15 is high when compared to 5. That symbol is upside arrow. This is 15, this is 5. The total will be 10. The total will be what? 10 amperes. Right? Now the same concept we are going to use for this. That is there is a voltage source in series with resistance, convert into current source in parallel with resistance. What it will happen is I am going to get a current source with the arrow this direction. Observe, arrow, how much it is? 2 divided by 0.1. Current is what? 2 divided by 0.1. How much it is? That is 20 amperes in parallel with a resistance of 0.1 ohm. Right? Then again convert this one. What is this voltage? 4 volts. I forgot to write 4 volts. 4 divided by 0.2. 4 divided by 0.2. This is 20 amperes. But arrow is this direction. Why? Your plus is this direction, minus is that direction. Yes, this is 20 amperes. And the resistance is this. How much is 0.2 ohms? 0.2 ohms. Okay. Just I am erasing this part because yes. Yeah, no problem. Come here. I have another voltage source in series with resistance. What is that? Yeah, how much this is? I think this is also 0.2 ohm, right? 0.2 ohm. Yes, that is first current. How much is the current? Current will be 30 this direction. Okay, just our question got disappeared. I was unable to recognize that. Our question got disappeared. Question is important for us. No, yeah, let me put here. this is a current source. Yes, how much it is? 6 divided by, how much is this? This is also 0.2. 6 divided by 0.2, it is 30 amperes. 30 amperes. And this resistance is also 0.2. All these are connected parallelly. This is 0.2. Now tell me, this 20, this 20 both are exactly opposite, therefore both will get cancelled. That resultant will be 0. Now what I am left with is, I am drawing the diagram very clearly here. You need not to bother. Yes, I am drawing the diagram here. I have a 0.1 ohm resistance. I have another 0.2 ohm resistance. Yes, I have another 0.2 ohm resistance, and I have one 30 amperes which is left with me. Why? Because previous 20 amperes gone. Okay, gone. This is A and this is B. Right? Now, this 0.2 in parallel with the 0.2, all three resistors are in parallel. If resistance are in parallel, R equivalent is equal to R1 R2 by R1 plus R2. Now what will happen is these two both are equal, no? R equivalent, only two I am finding, R1 R2 by R1 plus R2. What is R1 R2? 0.2 into 0.2 divided by 0.2 plus 0.2. The total that will be 1. 0.1 you get. 0.1. Now we have 0.1 ohms. This parallel combination became 0.1 ohm. This current source is how much? 30 amperes. This current source is how much, ma? 30 amperes. Now again these two parallel combination, R1 R2 by R1 plus R2, R1 R2 by R1 plus R2, come here. Now what is that? R equivalent is equal to 0.1 into 0.1 by 0.1 plus 0.1, that is 0.05 ohms. Now I have a resistance of 0.05 ohms in parallel with, yes, 30 amperes. In parallel with 30 amperes. Yes. Now current source in parallel with a resistance will be converted to voltage source in series with a resistance. I told you that is called as source transformation. Name is not required for you, but there is no harm if you are knowing the name, right? Now what is the voltage? Voltage is this current into resistance. How much is 30 into 0.05? It is 1.5. Yes, 1.5 volt. But plus is this, minus is this. I told you arrow direction will be plus, right? How much is this? Is 1.5 volt and 0.05 ohms. Yes. Now observe which option is suitable. 1.5 and 0.05 ohms. Option C is perfectly suitable for the given question. Option C for Chennai, right? Let us go for the next question. What is the resulting equation when Kirchhoff's loop law is applied to the following closed loop A, D, E, F, A? Let's mark it first. A, D, E, F to A. Now, before we write KVL, first of all, let's understand what is KVL. Kirchhoff's voltage law says that sum of all the voltages in a closed path must be equal to 0. Let me write. What is KVL? KVL is Kirchhoff's voltage law. It says that sum of, yes, sum of all the, yes, voltages in a closed path, must be, yes, equal to 0. This is one point. And another is current entering terminal must be taken as positive for a resistance or inductance or capacitance. Yes, another note point is the current entering terminal, yes, the current, yes, all of you, entering terminal must be taken as positive, must be, yes, taken as positive. Means what? Observe the diagram. Here I1 current is flowing. Now what is the voltage? Voltage for a resistance or voltage drop for a resistance is equal to current into resistance. See, I1 current is flowing in this R1, therefore some voltage is going to drop here, that is plus minus. Why here sir you taken plus? Current is entering here, and leaving here. What is this voltage drop? I1 into R1 is that voltage drop, right? I1 into R1. Now here I6 current is entering here, so this is plus, this is minus, this is I6 into R6 is the voltage drop, right? Now I4 current is entering here, this is plus, this is minus, I4 into R4 is the voltage drop here. I5 current is entering here, this is plus, this is minus, yes, I5 into R5 is the voltage drop there, right? Now for this closed loop he is asking, but the direction is asking to follow this way, A, D, E, F, A. He only mentioned the direction, right? Now I'll start at this A, I'll start at that A, okay? Observe it carefully. All of you tell me what should I write? All of you tell me what should I write? Yeah? Yeah, tell me what should I write? I6 plus I6 into R6 plus I6 into R6. Why plus sir? Yeah, I started at this A, I am encountering plus. I am encountering plus. That's why I am writing I6 into R6. Yes, and I am coming down, 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 down. I am going forward in the direction of D, E, F, A, but I encountered minus, plus, minus, plus, minus E2 please. Why minus E2? Yes, this way. Next I am moving forward, I am able to see what? Plus I4 into R4, plus I4 into R4. Let's go forward, forward, forward. Yes, I saw again plus, plus, yes, I5 into R5, right? Going up, up, minus E3. Why? Minus I am encountering first. Yes, minus E3, right? Going forward, forward, yes, minus I am able to see here. Why? Because current I1 is entering here, this is plus, that is minus. Very first thing I wrote there, very first thing, right? How much it is? Minus I1 R1 is equal to 0. Minus I1 R1 is equal to 0. Now, but our options are not in this format. In our options, all E terms are taken that side. Okay, let's write, no problem. Yes, I6 into R6 plus I4 into R4 plus I5 into R5 minus I1 into R1 is equal to E2, E3 I am taking to that side. So that is going to become E2 plus E3. Check which of the given options is going to match. Check which option is going to match. I guess, or why to guess? I can match here. Plus I6, this is not correct. Maybe plus I4 R4, this is not correct. Either B or C. Plus I5. Minus I1 R1, therefore C is also not correct. Option B is suitable. See, 1, 1, 1, 1 I eliminated. My answer is option B. You can check it very clearly. Option B is perfectly going to match for the answer, right? Option B. See, very easy, right? Let's go to the next question. Saying the resistivity of a current carrying conducting wire is rho. It is not P, it is rho. Okay, or in the examination paper, no, they give it as P, no problem. Symbol is not important for us. Okay, meaning is important for us. Resistivity. Okay, what is resistivity? I'll explain. If the wire is doubled in length and its cross-sectional area is reduced by half, the new resistivity is. One very simple important note statement is, yes, resistivity of a material, of resistivity of a wire, resistivity of a wire does not depend on the physical parameters, like physical parameters like length, cross section area, but it depends on, sir, it is not depending upon physical parameters, but on what it is depending? But it depends on the type of the material. Means if it is iron, whatever may be the length, whatever may be the area you take, iron resistivity is going to be fixed, right, on the type of the material. On the what? Type of the material. Here he said what? Only length of the wire is doubled and area of cross section is reduced by half. But he is not saying that material is changed. Material is not changed. Therefore, its resistivity is going to remain same. Resistivity is same as the old value. It is not changed. It's not changed. Let's go to the next question, please. And the resistance formula, you all know that is R is equal to, R is the resistance, rho L by A. Means if length changes, area changes, then resistance is going to change. But this rho is the resistivity which is a fixed value for a particular material. See, the resistivity of iron and the resistivity of silver may not be same. But if you take iron, whatever may be the length, whatever may be the area, its resistivity is going to be fixed. Its resistivity is going to be fixed. Next question, please. A battery of EMF 6 volts, yes, is saying that a battery of EMF 6 volts and internal resistance of 1 ohm, okay. This resistance is 1 ohm and this voltage is how much? 6 volts. It is what? 6 volts. Is connected to a resistor of 11 ohms. Yes, I am taking this resistance of 11 ohms. This is connected to this. This is the battery. This total is the battery. I am putting in the dotted lines. This total is the battery. The terminal potential of the battery is, he is asking, terminal means this is Vt. He is asking what is Vt. This is the battery, no? This is the battery. Terminal potential of the battery he is asking. Let's find the current first. As it is a series circuit, what is I? I is equal to voltage 6 volts. Resistance, what is the total resistance? This 1 ohm and this 11 ohm both are in series. 1 ohm and 11 ohm both are in series. Okay, then what is the total resistance? 1 plus 11. If resistance is in series, we can directly add. If two resistances are parallel, R1 R2 by R1 plus R2, right? Then what is the current? 0.5 amperes. The current is 0.5 amperes, right? Now write the KVL for this loop. For this small loop, you write the KVL. What is this voltage? Minus Vt. Just now I told you how to write the KVL. Wherever you start, again you need to end there only. Means you must form a closed path. I am starting at this minus, then minus plus Vt plus I into 11. Yeah. Why plus? This is, as current is entering here, this is plus, this is minus. What is this voltage drop? I into 11. Yeah. Minus Vt plus I into 11 is equal to 0. So from this one, Vt is equal to 11 into I is 0.5 amperes. How much it is? 11 divided by 2, it is 5.5 volts. It is what? 5.5 volts. Option is D for Delhi. Right? Option is D for Delhi. Yes, observe here. This is the option, 5.5 volts. Right? Yes. See how simple the questions are. Next question, please. If you see, most of the questions are related to voltage sources in series with internal resistances. Instead of saying it as voltage source, here in the questions it is said like a battery. It is said like battery, right? Yeah. A battery with an internal resistance of 2 ohms and an EMF of 4 volts. Yes. Internal resistance of 2 and an EMF of 4. Yes. This is 4 volts. This is 2 ohms. Yes. Is connected in series to a load resistance and the terminal voltage falls to 3.8. He is connecting this one to some load resistance RL whose value is unknown for us. Then he is saying that this voltage is going to become 3.8 volts. Okay. What is the current flowing in the circuit and what is the value of the load resistance? Okay. This is current, I assume it as I. Okay. Now this voltage drop will be I into RL. I into RL. Why? Because voltage drop is equal to current into resistance. What I do is, I will write KVL for this small loop. Yes, minus 4 plus I into 2. Why plus I into 2? As I is entering here, this will be plus, this will be minus 2 into I into 2, that is I into 2 plus 3.8 is equals to 0. So from this one, I is equal to 4 minus 3.8 divided by 2. How much it is? 0.2 divided by 2, that is equal to 0.1 ampere. I is what? 0.1 ampere. Now tell me, I will write a KVL for this loop. Then what I get? Minus 3.8 plus I into RL is equal to 0. So from this one, RL is equal to, yes, 3.8 divided by I got it as 0.1. Therefore, this is simply 38 ohms. So 0.1 ampere and 38 ohms. Yes, option is C. C for Chennai. Option is C. Yes, 0.1 ampere and 38 ohms. Let's go to the next question. Yeah, this question looks big, but solution is same as that of the previous. Okay, is saying two batteries, EMF 3 volts and internal resistance of 0.5. Yes, 3 volt, 0.5. This is 0.5 and this is 3 volts. This is 3 and this is plus, this is minus. What is this internal resistance? 0.5 ohms. Fine. And E2, 6 volts and internal resistance of 1. Yes, 6 volt, internal resistance of 1. This is 1. And how they are connected? By connecting the positive terminal of E2 to the negative terminal of E1. Okay, this is negative terminal of E1. This is the positive terminal of E2. Yes, this is the positive terminal of E2. This is plus, this is minus, this is 6 volts. This is the combination we got. This is the combination we got. Now he is saying a third battery of E3 of 6 volts internal resistance 1 ohm is connected in parallel with this combination by connecting the positive terminal to the positive terminal of E1. Okay, resistance. This is positive terminal to the positive terminal of E1. That is what is meaning. We implemented that. Now what is this volt? 6 volts it is. What is this resistance? This is 1 ohm. What is this question? Okay. Okay, he is saying that positive terminal is connected to the positive terminal of the E1 and its negative terminal to the negative terminal of E2. The equivalent EMF of this combination is asking what is this voltage E? What is that voltage E? Right? Just simply write a KVL. Find first current. Write KVL and find current. I am assuming current this way. Therefore, what is this is plus, this is minus I into 1I, and this is plus, this is minus 0.5I. Yes, 0.5I. Again, plus minus, this is I. Write the KVL. Minus 6 plus I, minus 6 plus I, minus 3 plus 0.5I plus I plus 6 is equal to 0. Okay, let's find the current first. Current is very important for us here, right? Now, 2.5I is equal to this 6 gone. How much we are left with? 3. From this one, I is equal to 3 divided by 2.5. Right? 3 divided by 2.5. Now write the KVL for this small loop. Yes, for this one you write the KVL. Minus E plus 1 into I is 3 divided by 2.5 plus 6 is equal to 0. So E is equal to 6 minus 3 divided by 2.5. Yes, how much it is? I can write it as 6 minus 3. 2.5 I can write it as 10 by 4. Right? 6 minus, how much it is? 12 divided by 10, right? 12 divided by 10. Am I correct? 10 divided by 4 is 2.5. 12 divided by 10. So it is 60 minus 12. 60 minus 12 divided by 10. I think it is 48 by 10. It is 4.8 volts. Answer is what? 4.8 volts. Option is D. D for Delhi. Question looks big, but here the logic is behind this diagram. If you are in a position to put the diagram, okay, he very clearly mentioned. I told you battery means voltage source in series with resistance, voltage source in series with resistance, but he told us very clearly how to connect it in the statements. The same statements we followed and we got the answer, right? Let's go to the next question. This is a combination of resistances. What he is saying, he is saying that two resistors R1 and R2 have their resistance values in the ratio of 3:5. So R1 is to R2 is equal to 3:5. So R1 by R2 is equal to 3 divided by 5, right? So from this one I can write it as 5R1 is equal to 3R2. This is the first relationship we got between R1 and R2, right? Then he is saying, yes, when they are combined in series, okay, series combination of resistances means directly addition of resistances. Their equivalent resistance is 24 ohms, okay. The individual resistance R1 and R2 are, he is asking us to find R1 is equal to dash ohms and R2 is equal to dash ohms, right? Now, what we got, 5R1 is equal to 3R2. From this, R1 is equal to 3R2 by 5. R1 is equal to 3R2 by 5. Substitute there, 3R2 by 5 plus R2 is equal to 24. 8R2 by 5 is equal to 24. 8 3s it is, that implies R2 is equal to 15 ohms. If R2 is equal to 15 ohms, substitute here, R1 plus 15 is equal to 24. So 24 minus 15, 5 plus 4, 9. Yes, R1 is equal to 9 ohms. 9 ohms and 15 ohms, option C. C for Chennai is suitable very well for the given question. You see, simplest question, okay, simplest question. If you know the concept series combination R1 plus R2, one equation and another equation, solve it, you get it, right? Next question, please. Again, see how important the concept of potentiometer. You see, potentiometer concept, batteries concept. Battery means not a chemical battery. So batteries representation electrically, that is important for us. Batteries, their connection, KVL, KCL, these are very important for us. Okay. Now he is saying potentiometer. One more question. Yes, what is saying? Consider a potentiometer setup where a cell of EMF 2.25 gives a balance at a point of 63 centimeters. He is saying that 2.25 volts we are getting balance at how many centimeters? 63 centimeters, right? Now the cell is replaced by another cell, okay. So he is saying that another cell E is taking, and the balance point shift to 21 centimeters. 21 centimeters. Then the EMF of the cell is, E is asking, cross multiply, or 2.25 divided by E is equal to 63 divided by 21. 21 3 times it is, that implies E is equal to 2.25 divided by 3. Third part of it, I think it is 0.75 or 1.25. Yeah, it is 1.25 plus 1.25 will be, check it carefully, the calculation, check the calculation carefully, okay. So or otherwise 0.37 cities, yeah, 21, then how much it is? 15, yes, 3 5s, 0.75 volts. Yes, it is 0.75 volts. Option A is perfectly suitable for the given question, right? Next, yeah, this question is also same as that of that batteries, but here instead of values he given the symbols. Read it. Consider two cells of EMF epsilon 1 and epsilon 2 with internal resistances R1 and R2 respectively. Okay, yes, this is R1, the EMF is epsilon 1 or E1, whatever it is, okay, is connected in parallel, okay. Then this is what, R2, yes, and this is epsilon 2, they connected these in parallel, okay, together, connecting the negative terminals together. The combination is equivalent to a single cell. He is asking, this is equal to some, this one R equivalent and this epsilon equivalent. Now get this R equivalent and epsilon equivalent is saying. Get this R equivalent and epsilon equivalent is saying. Now convert this into a current source. Yes, you get a current source, epsilon 1 by R1 in parallel with a resistance of R1. Convert this one also. Yes, epsilon 2 by R2, yes, in parallel with a resistance R2, right, R2. Okay, now epsilon 1 by R1, epsilon 2 by R2, both are in parallel. If two current sources are in parallel, they will be directly added. By adding, both arrows are up only. Therefore, the total current source is epsilon 1 by R1 plus epsilon 2 by R2. Yes, in parallel with R1 in parallel with R2 will become what? R1 R2 by R1 plus R2. Now current source in parallel with resistance will be converted to voltage source in series with resistance. Hauser, yes. Now multiply this current with this resistance, you get the voltage. Yes, this is the resistance. What is that? R1 R2 by R1 plus R2. Yes, and this is plus, this is minus. Yes, epsilon 1 R2 plus epsilon 2 R1 by R1 R2 into, yes, R1 R2 by R1 plus R2. R1 R2 gone, right? Now, yes, I am writing here. This is R1 R2 by R1 plus R2. Yes, this is what? Epsilon 1 R2 plus, this is plus, this is minus, please. Epsilon 2 R1 by R1 plus R2. You can check with the options. Check with the options which option is suitable for the given question, please. Which option is suitable? Okay. Yes. Observe the options. 1 2 2 1. Yes. 1 2 2 1. This is not correct. 1 1 only. This is not correct. This is not correct. Option B is perfectly suitable for the given question. So these are, see, this is a simple topic, current, electricity. From this one, these are the questions they asked previously. All questions, see, I give you the guarantee that from physics part, all questions without fail you can answer. Okay, because questions are not too tough. So I won't say easy, but they are not too tough. If you know, if you learn the concepts in right direction, then for sure you'll be able to answer every question without fail in physics for AAI ATC examination, right? So YourPedia started a dedicated module for AAI ATC preparation. You can join your hands with YourPedia to accelerate your preparation for AAI ATC preparation, right? And subscribe to this channel to get more this kind of videos for your preparation. Thank you.